Assalamualaikum and hello everyone. My name is Hariz Azfar bin Muhammad Hide from 3BMMA Session 2/1, and today I'm going to present about my final year project, which is Design and Fabricate Portable Waste Engine Oil Filtration Unit for Automotive Services Center. And my supervisor is Dr. Muhammad Ilman Hakimi Chua bin Abdullah. So, content of my presentation for today is the background, problem statement, objective, project scope, product design, technology for fabricating, and lastly analysis of the product. As for the introduction, engine oils is created by combining crude oil and its derivative with other chemical or additives to improve their properties. Lubricating oil used to lubricate engine or moving parts, reduce friction, protect against wear, eliminate pollutants from the engine, and act as a cleaning agent, anti-corrosion, and cooling agent. As for the waste engine oil, is a high polluting substance. Used lubricant engine oils are byproduct of oil used in vehicles and machinery. And as for the aim of this project, it is the most of the technology to filtrate the waste engine oil comes at a high cost. As a result, the aim of the study is to discover a low-cost method of producing used engine oil. This research is to recycle used engine oils. Most engine oil contains a lot of different chemicals with very different properties, from Demibus 2008. The problem statement of this project is that the engine oil must be changed from an automobile after a few thousands of kilometers or when it is no longer serve a purpose that is fully reliable. Next, changing the engine oil would produce a waste engine oil, which is a high pollutant material that requires a proper management. And lastly, waste engine oil may cause damage to the environment when dumped into the ground or into the water stream, including sewers. As for the objective of this project, firstly, it is to design and simulate a portable oil filter by using SolidWorks. Secondly, it is to fabricate the portable oil filter with suitable filtrating material. And lastly, to test the development of oil filter compared to lab scale. Next, we go to scope. The scope of this project, it is to designing and testing the performance of the portable oil filter with SolidWorks and analyzing the design product in the spec of structure using the tools in SolidWorks. And next is fabricating the portable oil filter with analyzed suitable oil filtration membrane and lightweight oil corrosive durable material. And lastly, testing the fabricated oil filter compared to lab scale filter unit. Next, for the next part, we jump into the methodology of this project. The design of the portable oil filtration unit is developed by using SolidWorks 2021 software. Why I'm using the SolidWorks 2021 software? Because it is capable of making an accurate drawing with the 3D display. Next is it provides features such as the material use and analysis that can be beneficial for testing the desired function of the product before fabrication. And lastly, the result drawing can be used in 3D printing, which in this case I use the SLS printing machine. So this is the blueprint of my design. There is the top view of the design, bottom view of the design, and side view of the design, and lastly the 3D view of this design. The design consists of 7 parts, which is for the part 1, it is the collector, the head of the design, where the waste engine oil flows into through this collector. For part 2 is the filter paper, where the waste engine oil undergoes filtration, the first filtration process. And part 3 is the body, it holds the waste engine oils to prevent it from leaking during the filtration process. And part 4 is the filter paper, where the waste engine oil undergoes second filtration process. And part 5 is the body. Part 6 is the reservoir tank, which the end product of the engine oil is accumulate at the reservoir tank. And lastly, part 7 is the base. It is to ensure the stability of the design. Next, we go to the material selection of the design. The SolidWorks 2021 software provides features for the designer to assign the type of material for the design and its properties. Testing and analysis the assigned material for each part of the drawing will be conducted. This is to ensure the effectiveness of the design before fabricating. So this is the material testing that I have done for this project. I used the 1060 alloy as the assigned material for this tank reservoir. The tank reservoir shows a deformation. Therefore, the material selected for the part is not suitable as it could not withstand the force that will be applied to the part's surface. Next, we jump into the technology used for fabricating. I use the laser cutting, a technology that uses a laser to cut material, a lathe, a type of machining tool that is used to shape hard materials, and lastly, 3D printing, in this case, SLS printing technology that convert powder form material into a desired three-dimensional shape after being heated. For the laser cutting, it is a high power laser beam that is emitted by the laser cutting equipment to either cleanly cut or etch a specific design on materials such as steel, plastic, or wood. The beam will either burn, vaporize, or melt away the excess product, leaving a superior finished pattern or edge. Lastly, the raw material will be cut by using the laser cutting machine equipped in the manufacturer laboratory. So this is the schematic design of this laser cutting machine. Next is a lathe. The workpiece is rotated around a stationary cutting tool. It is really useful in the process of fabricating a cylinder-shaped material, and it is used to fabricate the body of the filtration unit as the as it is suitable for cylinder-shaped material. This is the schematic diagram for the lathe machine. And lastly, it is 3D printing, which is SLS printing. The fusing process begins at the top of the design and continues through a cross-sectional view from the top perspective, allowing the powder to harden layer by layer. A technology that has a low cost per part, high productivity, and established materials that make it ideal for a variety of applications. Therefore, it is a low cost part. It is suitable for the objective of this project to produce a low cost product of filter waste oil filtration unit. And lastly, analysis of the product. SolidWorks static. This product consists of SolidWorks static analysis, SolidWorks displacement analysis, safety factor, computational fluid dynamics (CFD), and Archosaft computational fluid dynamics. SolidWorks static analysis. It is a simulation provides many load conditions to apply on the product surface, such as force, pressure, and maximum load distribution for analysis. Stress, strain, and deformation of a component or assembly can be analyzed under a range of load conditions to ensure that costly failures are avoided during the design stage. These analyses are evaluated to examine the effect of the working environment and operating condition of the design based on the material chosen. So this is the static analysis that I have done to the reservoir tank, and it shows that there is a red part and there is a orange part, which shows the material assigned for this part is not suitable. Next is SolidWorks displacement analysis. The displacement analysis will produce stresses and displacements as the output when force or loads is applied to the product design. It performs deformation animation of the product design. So this is the result of my displacement analysis to the reservoir tank. And next is the safety factor, the ratio between the strength of the material and the maximum stress in part. That is the definition of the safety factor. It is described as the structural capacity of a system's ability to withstand loads that are higher than planned or actual. Safety factor must be at least 2.0. The higher the safety factor, the more reliable the design. And this is the formula to calculate the safety factor. The yield strength and the volumetric strength can be obtained through the SolidWorks 2021 software. And lastly, the computational fluid dynamic (CFD) and the Archosaft computational fluid dynamic. Computational fluid dynamics (CFD) is the mathematical modeling and numerical solution of a physical phenomenon involving fluid flow and heat transfer. CFD simulates fluid dynamics in a virtual environment. It is to provide capability comparable for computer-aided engineering tools by significantly reducing lead time and expenses of new design while also increasing the ability to investigate the system. And for the actuals of computational fluid dynamics, it provides fluid flow, heat transfer, turbulence, and non-Newtonian material simulation on totally unstructured meshes. The solver will validate these physical models. It is to analyze the design product capability to withstand the fluid flow and the temperature in order to function effectively. So we can test the capability of the product to withstand fluid flow and temperature before fabricating using the attributes of computational fluid dynamics. So that's all for my final year project presentation. Thank you for thank you for lending me your ears and hoping to see you again. Thank you.